Going live.
I like them a lot too. I was wearing a tank top. My son was wearing a tank top today. It was also red and white stripes, so it wasn't as red.
A lot of those computer moves, are incomprehensible to even like top players. They just don't really understand. There's a huge difference between like computer chess and human chess. Even like high level human moves, even like someone like me can understand the general idea, but a lot of times the computer will do something and it's just like, we don't know why they did that. Anyway, and then later on, a lot of times the really interesting ones, there's videos on YouTube you can watch where they do something really weird and then like 20 moves later they go, oh, now we see what that was. Anyway, so pretty fascinating.
Yes.
Neato.
Poggers, just, so hey, send some poggers to Griffin. Okay, guys. So like I said before,
Yes. You have to know this one.
Oh yeah.
you
It
got
has to be black.
average rate of change. So a lot of times, I forgot, like that money example. So what I was saying before was,
That would be lit.
okay, so this is like your stonks. Yeah, so this is your money, this is your time. As you can see, like the overall rate of change. So the average rate of change, like in our example, we said $1 million and it took 25 years. Okay, great. So your average rate of change is 1 million divided by 25, right? So what's that? 40,000. So that's 40,000 per year is the average rate of change over this interval. But, now they say this is your retirement account, you need to have like a Zen mentality, because if you get too focused on your instantaneous rate of change, you're gonna stress yourself out because you take like a dip here. So what's the instantaneous rate of change right here? Negative. Oh, I'm losing my money. So the same thing happens, if something is, say this could be temperature. This could be temperature over time, for example. And it could go like this, right? So you could have an overall average rate of change that's positive, but then you can be like, oh, it's really steep here, not very steep here. Now it's negative steepness. You get the idea, right? Is that?
Yeah.
Yeah, so negative slope. So if your slope is negative, that means in this case, if it was temperature versus time, a negative slope would mean cooling. You're cooling off. You're getting less hot.
Yeah.
Here, a negative slope means you're losing money. Okay, so that's your investment, and the price drops. So say your entire investment was in TikToks.com, which I strongly recommend, obviously. Put all your money in one company. That's what you do. Some really volatile company that can go out of business. Just kidding.
Anything based on the internet trends?
Yes.
Is the way to go.
Yes. Take all your money, put it in Snapchat. Boom.
Well, actually, that's not the worst idea.
You can sue.
I do have one share of Snapchat. I know I'm a Warren Buffett type. I won. We'll see.
I don't want to know.
Okay, so anyway, guys, in this first question here, with the little curvy curve, what do we think is the average rate of change between -1? Let's go over some notation here. Those little brackets are talking about an interval. Do you think it's an interval of x values or y values? It's x values. So the average rate of change between -1 and 0 is +1. Rise over run is 1. B, between -1 and +1, what's the average rate of change now? Okay, you guys get the idea, right? So fill out the rest of those real quick. And then try to estimate the instantaneous rate of change. I'll just quickly show you what that looks like. It's what we call a tangent line. So like, say you want to know the instantaneous rate of change over here. What you do is you just imagine a line. It's the same thing if you think back to geometry class, like, oh, there's a circle. Here's a point on the circle. Where's the tangent line? The tangent line just touches. Now this is the tricky part. This confuses people. It touches once locally. So for example, let's say I want to do the average rate of change here. It touches one time. When I say locally, I mean like in that little neighborhood there. it's just going to cross once. It could cross the curve somewhere else, but just in that little neighborhood there, it's just going to be tangent to the curve. Does that make sense?
Yeah.
Okay, so fill out the rest of these. Make sure you understand it. We'll go over the answers in a minute or two. That was very nice, George. Thanks for sharing your beatboxing skills with us. Very lit and savage.
Can't say savage. Can't say.
Shut up, Jesse. I'm sorry, we listened to it in Spanish. It's a musical song. It just reminds me of Betsy, and I hate it. Oh God, Betsy. It's a good song. It is a good song. See, it's gonna be stuck in my head. I'm sorry, it's just stuck in my head. There's definitely stuck in your head. Like Galactic Mermaid. I know that's the one of it. I know. I saw your Snapchat. I was attempting to sleep at that point.
What's up?
But I don't think I slept at all.
Huh?
Yeah.
Yeah.
I hate it.
I'm guessing. Sorry, I don't know how to do any of that.
Okay, I think that's what it is, but who knows? Why are you doing the tangent lines first? Because I already drew them. Okay. Now I'm confused. 1 to 3. -3. That would be like -1. But I don't feel like that's correct. What would you do it? That is the question. Oh, goodness. What was that? Oh, wait. Maybe I was. No, I wasn't. I wasn't.
All right, guys, try to finish up those estimates, those instantaneous rate of change estimates. They're just estimates, but there is actually there's some more nuanced things to think about. So like, well, let's just check the answers. Run the first problem, so let's make sure no one's confused here. A, you should have got 1. B, you should have got 3/2. C, what do you get on C? 4/3. Then what do you get?
3/4.
Very good. Then you get from -1 to 4. What's the answer? 0. Very good. So the average rate of change could be 0. You could go up. You can come back down to where you started. Average rate of change is 0. From 0 to 1, 2. Okay, you guys get the idea. The only, I guess maybe make sure you got a negative number for H.
Yeah.
Because from 2 to 3, that's a slope of -1.
Yeah.
From 3 to 4, it's a slope of -3. And then from 1 to 3, of course, its slope is 0. No questions before we move on? Good? Okay. So first, some notation. This, you read, this is not a 1. This is a prime. That symbol is called prime. So the way you say this is f prime of -1. So this is going to be new to you. I don't think you've ever heard that before. It's a calculus term. So it just means, basically, that just means the instantaneous rate of change, aka the derivative at -1. Okay, so again, f prime of -1. Who's got an estimate for that one?
I do.
What do you got?
1.
1's pretty good. Think about this. I think that 0.9 is a little bit better of an answer.
0.9.
No, Trey, no. Do it to me. And here's why. Do you see how on this part of the curve, would you agree that the slopes are increasing? The slopes are getting more slopier?
Yeah.
Slop, exactly. So now this is what I said, this is kind of a nuanced thing. The answer of 1 is a fine answer, but start to think about this curve. So, not very steep, steeper. So you can see that between 0 and 1, the slopes are actually getting bigger. So if the average rate of change is 1, and they were increasing the whole time, it stands to reason that over on the left-hand side, the slope was less than 1, and on the right-hand side, it was a little bit bigger than 1. So I think a more demonstrative answer here would be that, okay, at -1, maybe it was 0.9, again, just an estimate, and maybe at 0 it was like 1.1. Now again, those are just guesses. The fact that their arithmetic mean is 1 is just a coincidence. In fact, I don't know. Just to avoid that confusion, I'll make it 1.2. So there's no simple relationship like, you just take the two derivatives and they average out. No, that is not the case. It's much more complicated than that. So does that make sense what I was talking about as far as like why it would be smaller on this side than on that side?
Yes.
Okay. So then L. I guess we're just that one. Sorry. L, f prime of 0, something about 1.1, 1.2, 1.05, whatever. F prime of 1, that one's weird. It's actually changing from, if you look at the curvature, it's actually changing from what we call concave up to concave down. We'll get into that later, but an answer like 2 or would be fine. That one, don't get too hung up on. That's a weird one because it's changing from, the curviness is changing from increasing slope to decreasing slope at that point. What's up? Oh, these ones? Oh, so we're going in the graph and just kind of drawing a tangent line. So like here, just kind of either eyeball it or actually draw it in, and then just guesstimate. How steep do you think that line is? What do you think the slope of the line is roughly? Does that make sense? So like on part M, when it's asking f prime of 1, we're coming over to this point here and going, I don't know, how steep does that line look? And use the grid to your advantage. I don't know. I'm thinking it's something like maybe it's 2, maybe it's 2.3 or something. I would argue it's a little bit bigger than 2. But again, we don't want to get lost in the weeds here. This is just trying to get a general sense of what a derivative is. Jesse, f prime of 2 is 0. That one we have a definite answer to.
Yeah.
That point is pretty clearly at the top of that hump. And if you draw the tangent line, you can see that f prime of 2 is 0. How about f prime of 3? I don't know. I'm guessing it's like, I would go, my answer to that would be negative 2.5 because it's going to be less negative than negative 3. So like, what I mean here is, so here's point E, here's point F, right?
Yeah.
What's the average rate of change between E and F? -3. Now, would you agree that at point E, it's less slopey than the average rate of change between E and F?
Yeah.
So an answer like -2.5, maybe 2.7, whatever you want, I just would say an answer like -3 is not a bad answer, but it kind of misses the point of what's happening to the slopes as this graph changes. And then so on the same line of reasoning, question P, what do you guys say for f prime of 4? What's a good answer for that?
-4.1.
I like that answer. That's a good answer.
Right.
Sure. -4.2 if you want.
Oh, wow. See, I put -2.47 for O, just for funsies.
So for f prime of 3, I think any answer that's kind of close to -3, but not as negative. So a number that's greater than -3. So something like really fancy, -2.7. Pretty fancy, huh, Emily? Sorry if that was too bougie for you. Okay, now let's do some calculation. So all that stuff was just kind of conceptual, just general, like, hopefully you have an idea now of what the derivative is. The derivative is just a measurement of what is the slope of the tangent line at that x value. That's all it is. What is the slope of the tangent line at that x value? Okay? AKA the instantaneous rate of change. Okay? Alrighty. Number 2 says, find the average rate of change of this function on the interval 1 to 5. So I'm going to show a graph for this one because you don't have to graph them all, but a graph is a good way of understanding how simple the calculation is. If you look up a formula, you'll find something like this. If you're wondering, oops, sorry. Certainly good to understand the structure of formulas like this. Like, what do they say? So there's your average rate of change formula, but let's try to understand it in simpler terms. It's literally just rise over run. That's all it is, rise over run. So if I were to graph this function, I'll graph it real quick. So asymptote at -3, has the point 0, 0 on it, horizontal asymptote of 1, y equals 1. So the graph has to look like this. Okay, so graphing it, it's pretty straightforward. Now on the interval from 1 to 5, I can go, here's 1, here's 5. So by graphing it, what kind of number should we be looking for? Yeah, a not very big number. A number kind of close to 0.
Small boy.
It's also positive, right? Yeah. So really all we got to worry about is what's the rise over run on this interval from 1 to 5. So I already know what I'm going to be dividing by, don't I? By 5 minus 1, by 4, right? The run. Yes?
Yes.
Okay. How do you find rise? How will I find like the rise here? What do I got to do in the 1 and the 5?
Plug them in.
I got to plug them in. So I got to find the y value here. I got to find the y value here, right?
Yep.
How did I find the y value here? Well, plug 1 into my function. So 1 over 1 plus 3, it's a quarter, great. Let's find the y value here. Plug 5 in, we get we're okay with that?
Yep.
Okay, so do you see, is this formula maybe
Yes.
being clarified now?
Yes.
Oh.
So in this particular case, it's f of 5 minus f of 1, also known as rise. On bottom, it's 5 minus 1, also known as run, rise over run.
Mhm.
So let's do the calculation now. The average rate of change is, I'll clarify it here. It's f of 5 minus f of 1 over 5 minus 1. Okay, so it's 5/8 minus 1/4 over 4. Very good, yeah, so this is 2/8. So 5/8 minus 2/8 is 3/8. Yeah? And then 3/8 divided by 4 is 3/32. There you go. So we know, so that confirms our suspicion. That confirms our suspicion that the answer was a positive value and was also not very big. So this is one of the reasons why, I like graphs so much as like a tool for, most importantly for understanding things, but two, like taking a test, kind of standardized test. And yeah, there's a question like this and a quick sketch of the graph maybe narrows it down to 2 choices or whatever off the bat. So, okay, let's move on. Why don't you guys try the next couple? Okay, so the rest of this page, or just do 3 and 4, I guess. I'll go over 5 because it's a little different, but feel free to move on and do 5 if you feel like it.
Oh my goodness, I can't do that. Mhm.
All right, I hope you had enough time to at least get 3 done to make sure you're not lost. You should have got, what is it? Is it 11?
Yeah.
Okay, 11. So, is everyone able to get 11?
Yes.
You sure? Question? Okay, good. All right. So, I'll go over, I'm sure you guys could have figured this one out, but just to be safe, let's go over it. Number 5 says, can we find, well, first I guess you got to parse the question. It says the average rate of change of the function y equals x squared over the interval from 2 to a is 8. Find a. So that basically is saying there's some interval out there from 2 to a, so a is clearly an x value. It suggests that a is bigger than 2, and the overall slope from 2 to a has to be 8. So the slope is 8, so average rate of change is 8. So we can do it really formula-y.
I like
Yep.
this question.
So we can say, okay, well, the formula for average rate of change, you don't have to write out the formula, but every single time. So as far as showing your work, I don't think that's necessarily necessary, but you certainly want to at least show something like, you want to show the form. So 8 equals, what's f of a?
It's a squared.
Yeah, so look at the y values. The y value at 2 is 2 squared. The y value at a is a squared. So the y value here, so a squared minus 4 over a minus 2. Now, in these kind of questions, if this is a standardized test, certainly guess and check. If it's a multiple choice, guess and check's a valid approach. Here, I mean, so we're trying to practice good math. So like, okay, we want to show that there's definitely only one solution to this. Seems maybe a little obvious if you think about the way this graph is getting steeper, that there's only one solution. But anyway, so we're to solve this. There's actually a very sneaky way to solve this. Does anyone think they see it?
Is it that you can do the factors and
Yeah, so you could multiply this over to this side and end up with a quadratic form, but much sneakier to do this. Factor the top
Yeah.
into a plus 2 times a minus 2,
my mind just went there.
and they cancel-y-wancely.
Yeah, same thing.
As long as a isn't 2, you're okay to do this, which obviously the answer is not 2. So, and we get our answer. So so after they cancel it out, a plus 2 equals 8, so it turns out that a must be 6.
Yeah.
Big deal.
But how does that? It's asking for like what we did over here on number 1 on like the very first page with the slope between them. So
It's asking for the average rate. It's saying the average rate of change is 8. So in hindsight, so in hindsight, this number turns out is 36. So the rise is 32, the run was 4, so we get the average change of 8. All right, guys, last couple of things today. Where was I? So you got a little bit of work to just finish on your own. The questions should be pretty straightforward. The only one I maybe want to discuss tomorrow is on number 10 asks you to explain what this means in plain language. So I'd like to hear your thoughts on what that means. Yes, Aiden? We'll do that in class tomorrow. Thanks for pointing that one out. I'd like you to try it. You don't have to do it tonight, but your homework at this point is to finish through.
Many.
Sorry, I got my pages mixed up here. My bad. We're going to talk about 14 tomorrow in class. Actually, I'm going to touch on 14 today. So I would like you to try to think about it a little bit, but because you know how to do 12 and 13, right? Okay.
Probably.
Well, we already talked about 12 and 13. So you're just ranking the derivatives. Keep in mind that
She does.
Keep in mind that a negative derivative is less than a positive derivative. So like on number 12, what is in this ranking, what is the least derivative? It's at A, because A is clearly a fairly large negative number. So the last thing I want to talk about today, guys, is just we'll go over it in detail tomorrow because it's very important for understanding derivatives, but some food for thought here. 14 says, for each function below, sketch a graph showing the function's tangent lines at various x values. Think about how the derivative of the function must behave, and use this information to sketch a rough graph of the derivative. So, what does that mean? If you ever have a question like this and you're unsure about the directions, it's always good to just start with the simplest direction. So it says, okay, sketch a graph. All right, well, luckily I know how to sketch this.
Similar to those questions in physics where you have to like find the slope. So okay.
Yeah. So this is my graph. This is my function. Now it's and the next thing it says is draw the tangent lines at various x values. Okay, so let's just pick a couple. 0, sure, that's always a good one to look at. What's the derivative at 0, you think? 0. How about over here at some positive x value? Okay, whatever that is. Maybe one more positive x value. Now why did I pick 2 positive x values? I wanted to show myself what's happening to these derivatives as I move to the right. They get greater, yeah, they get larger. Let's go on the left side of the graph. Okay, I got a negative derivative, and I've got an even more negative derivative. So, what we have is this idea on the graph of, okay, when is this guy's derivative negative? Maybe I should say where. On the left side, whenever x is negative. So there's a whole bunch of mathematical statements you could potentially write about this. You could say, if x is negative, f prime of x is negative. If x is positive, f prime is positive. And then lastly, what if x is 0? What do we get on our graph? Or actually, this I can actually just write like this. The derivative at 0 is 0. That's what this line says. I don't even need this little implication arrow. So here's the fun part. This part's certainly, right now with our techniques, it's not possible to get an accurate graph. Sorry. Because we don't know exactly what is the derivative of a parabola precisely. And I'll just give you, the answer here. So ask yourself, does it make sense why the graph could look like this?
Yes.
So yeah, we ask ourselves, does that sit right in my mind? That, okay, does this agree with all this? For positive x values, I have positive values. Now, does it make sense? Let me make this statement here. The slopes on this graph tell us the y values of this graph. How about that? Does that make sense?
Yeah.
The slopes on this graph tell me the y values on this graph. So let me give you an example. Let's say the slope here was 6, the y value is 6. So think about
that
it.
line be straight?
It is. It's linear. Yeah. We'll go over this in greater detail tomorrow. We're going to go over the definition of the derivative and all that fun stuff. So just try to knock out a few of those amplitude change problems and think a little bit about this.
I